Okay, example 2, we have some vector operations to deal with, and the first one is a new operation. You've never seen this one before. It looks like absolute value bars, but it's like more powerful absolute value bars. It's like double absolute value bars. This is the magnitude operation. Okay, if you go back to, again, Algebra 2 ideas, when we had a rectangular form and we wanted to go to polar form, the first thing was to find r, right? The magnitude of the vector, the length of the vector. All right. If you have a vector which is 4, -1, which is w here, because that's what they're asking me to go back to, the magnitude of w, what I want to do is find the length of that vector. Its component form is 4i minus 1j, and the magnitude is just going to be the square root of 4 squared plus 1 squared. Squaring creates positive, so ignore any minus signs in that process. So even though it's 4, -1, -1 squared is the same as +1 squared. Don't put the minus sign in there to make your brain think, well, maybe it's supposed to be negative this time. Even though it's never been negative before, I really want it to be negative. So don't do that. So 4 squared is positive, -1 squared is positive. So just put positive numbers there. So 16 plus 1 is 17. So there's your magnitude. Okay, so that's for magnitude. That's all you have to do. Okay, that is not a vector. That is a scalar value. It's just a number. If you take a look at a vector addition problem, vector plus vector, what we're doing is taking vector v, which is -2, 3, and adding it to vector w, which is 4, -1. And we've already done this in Algebra 2 also. When we did the I and j form, plus the I and the j form, we could add the i's and add the j's to get the answer, right? That's all that's happening here. We're adding these vectors in component form. The x component make the x component. Y component make y component. Creating our answer. Part C, -3 times v. So this is called a scalar product. We're multiplying a scalar number times a vector. Okay, I'm going back to what I just mentioned on the last problem. These vectors are the same, right? If you multiply a vector, what you're going to do is you're going to create a longer vector in the same direction. It changes the magnitude, doesn't change the direction. So whether it's, let me just give you a right triangle here. Suppose I have a 3, 4, 5 right triangle. 3, 4, 5. So this is 5, right? And it's going in this direction, which is 53.13 degrees or so. All right. If I made it to 6, 8, 10, so now if I do this vector here, this vector's length is 10, but its angle is still 53.13. All right? So 6, 8, and then 10, this was 3, 4, and 5, right? Double, double, double. Everything doubled, but the direction's the same. All right? So when we're looking at a vector and we multiply by a scalar amount, the components are just going to be multiplied by that amount. So if I look at -3 times v, it means -3 times -2, 3. It just means -3 times both numbers. So it gives me +6, -9. And that's the product of a scalar and a vector. A vector times a vector is a little more complicated than that. We aren't going to do that. But if you're just multiplying a number times a vector, that's all you got to do. Each component gets multiplied, and that creates the correct product. And part D combines a little bit of B and a little bit of C. So we got some multiplication and we got some subtraction, which is in the same family as addition. All right. So we look at 2v. That's 2 times -2, 3. Minus 3w, so -3 times 4, -1. I would multiply 2 times both those, so I get -4, 6. For me personally, I'd multiply -3 through here, so it's going to be -12, +3. And since I multiplied the negative, I'm going to put a plus sign now between them. You could also multiply a +3, keep a minus sign between them. Your choice. All right. But if you do multiply the -3, so both of these, -3 times 4, -3 times -1, created this product. Because you've already dealt with the negative sign, now it's a plus sign. And then adding the vectors just like I did up here, x plus x makes x, y plus y makes y. Same addition rules as we've always had for sign numbers, same sign add, different sign subtract. answer is the sign of the bigger number. In both cases, the signs are the same. Added, added, negative, positive. Each time we're getting a vector answer. When you're adding vectors, you get a vector answer. When you're multiplying vectors, you get a vector answer. When you're multiplying and adding or subtracting, you get a vector answer. The only time you get a non-vector answer is when you do a magnitude, then you just get a scalar number.